Hey everybody, Mr. Grove here. Today we're going to talk about motion and free fall problems, and I've got a few examples that we'll work through. So when we're doing motion, the four formulas that we'll be using are these four formulas up here, and they are all derived algebraically from each other, so they can kind of be substituted in and out of each other. But the variables stand for VI is going to be initial velocity, final velocity for VF, T for time, A for acceleration, and D for distance. And so when we set up a problem, I would recommend kind of having a little data table over here that you can put the things that you know into the problem, and then that helps give you clarification on what you're going to solve for. So for this example, our car is accelerating from rest. So since we're from rest, we know VI is going to be 0. And it reaches 30 meters per second, and it does so in 8.4 seconds. So these would be the things that we know, and then what we're trying to solve for is the acceleration and the distance. So using the formulas that we know the most about, so in this case, we really know VF, we know VI, and we know T, so this first equation would work really well to solve for that. So 30 minus 0 VI over our T, 8.4 seconds. And so we just have to be consistent with our units. So 30 was meters per second, 8.4 was seconds, and so that way we will have meters per second, which would give us acceleration. And so in this particular example, we get 3.57 meters per second squared. And acceleration will always have the unit distance per time squared. Once we know that, then we can use, again, whichever equation will help us solve for the remaining pieces. So in this case, our distance equation right here, we don't know distance, but we know the VI was 0, 1/2. We now know acceleration, and we know our time. So let's just put that in there. So distance, VI was 0, so that means 0 plus 1/2. And then our acceleration that we solved for in the previous part, 3.57 meters per second squared. And then that will allow us to solve for T squared. We know T is 8.4 seconds. So that is squared. Okay, so when we plug that through, solve for our distance, we would come up with 125.9 meters. And so that would be an answer. And then our acceleration was 3.57 meters per second squared. So that's example number 1. Let's try example number 2. So on this one, we've got a car going at 18 meters per second, and then it's going to stop, come to rest, and it does so over a distance of 38 meters. So we don't know these two items here. So again, picking whichever equation, we can't really use this first one because we don't know A or T. We can't really use this one, we don't know A or T. Can't really use this one, we don't know A or T. So by default, really this last equation is the only thing we have the information for. So we can plug in 0 for VF equals the square root of VI squared, so that's 18 meters per second squared, plus 2 times A, we don't know, times D, 38 meters. So mathematically, this is a little trickier, so you've got to do your algebra. So square both sides, and then so 0 squared would just be 0, and squaring this side would get rid of the radical. So then we have 18 squared, and if we pull that over to this side, that'd be negative 324, equal to then the 2 times A times 38. And so when we solve for A, we would get a negative 4.2 4.26 meters per second squared. And that's okay to have a negative. That just means we're slowing down, which should kind of make sense since we started at 18 and came to a stop. Once we know that, then we can use, again, whatever formulas we need to try and solve the other part. So I would say let's just use this first equation. We know 0 was our final, minus 18 was our initial, over t equals the a we now know is negative 4.26 meters per second squared. So if we bring that down, bring this up, and we solve for t, we should get 4.23 seconds. So that would be our unit, and that would be our answer. Okay, so those are some basic motion problems. Notice we're going in one dimension in one direction. So that will change as we get a little bit further into the chapter. Let's try a couple of free fall examples. So with free fall, the factor that's making something fall is going to be gravity. So our gravity acceleration, we will always use 9.8 meters per second squared as our constant. You can also use 32 feet per second squared if those units are more applicable to your problem. So in this case, we're dropping a ball from a 50-meter tall tower, so we know 50 meters. We know gravity is 9.8 because that's constant for free fall. And we know we're dropping it, so we're not throwing it, we're dropping it, so VI is going to be 0. So at this point then, we can solve for what we need to know. So let's solve for t. We can use the third equation because we know distance, we know our VI, and we know our A. So all we have to solve for is t. So our distance is 50 meters equals 0, VIT would be 0, plus 1/2 AT squared. So A being 9.8, T squared. So if we solve for T, we're going to get 3.19 seconds. Okay, and that will be our answer. Now that we know that, then we can use any of these equations to solve for VF. I'd probably say this guy here. So VF equals, again, VI was 0, so plus AT, so that'd be 9.8 times my 3.19 seconds. And so that's going to give us a VF of 31.3 meters per second. Okay, and so that would be my final answers for both of those problems. Another example, again, free fall. So we're dropping an object, not throwing it. So 0, we're dropping it. So it's gravity, accelerating it down. And we don't know the distance, but we do know the time, 3.3 seconds. So again, which of our formulas gives us the most information? So I'd say probably this last one because we know VI, we know T, and we know A. So solving for that, VI was 0, so that all turns out to be 0 times 1/2, 9.8, times our time squared, so 3.3 seconds, and that's squared. And so our distance turns out to be 53.36 meters. So that would be our answer for the depth of the well. And then our final velocity, now that we know that, we can use any of these that would give us that final velocity. Again, probably the second equation is already solved for it. So VF equals 0 plus AT, so that's 9.8 times 3.3. And we would get a VF of 32.34 meters per second. So that is how we do some motion problems and some free fall problems. Notice they're both going in just one direction though. Free fall down and the motion was going in one direction. When we change to two directions, things are going to get a little bit more complicated, but that'll be okay. And I hope all this was helpful.